All right, everybody, this is the Algebra 1 video on 9.3.1. I'm going to do a little bit of what they're doing in the book, but I'm also going to start off with a little bit of review because this is a new week. So if I ask you guys to solve something like, so this is review. If I would ask you to solve something like 4x minus 5 is greater than 22. All right, so I'm asking you to solve that, and then I also want that on a number line. So the first thing you do, and if you have to make a line through, you can, I'd subtract 5 from both sides. Does subtracting 5 from both sides change inequality? No. So that's going to be 17, and this is going to be a 4x, and this is going to be greater than. And I'm going to divide by 4. All right, so then dividing by 4, does that change it around? No. So x is going to be greater than 17/4, or you could say x is going to be greater than what? 4 1/4? So if I'm on a number line, I got 0 and then 4 1/4. We are not including 4 1/4, so we're going to have an open dot, and I'm looking for the x's to be greater. I'm going off to the right. All right, that would be in comparison to number 2. Well, let's say I have 7 minus 9x is less than or equal to 32. All right, so same thing. First I'm going to subtract 7. So I get negative 9x is going to be less than or equal to, because that doesn't change because it's subtracting 7. 32 minus 7 gives me 25. And divide by negative 9. So when I divide by negative 9, I get x. This does flip around because I divided by a negative 9. And I could say x is going to be greater than or equal to 25 over negative 9, or x is going to be greater than or equal to 9 goes into 25, what? 2 times. And then there is 7/9 left over. So here we go. 0, negative 2 7/9. It's going to be a filled in dot because it's equal to. X's have to be greater. We're going off to the right. So that's what I'm looking for here. All right. So the very next question, so they kind of talked a little bit about different kinds of solutions. But in question 966, so really what I'm going to try to do here, you guys, is I'm going to do question 966, which kind of flows into 967, and I'm going to look at 968. So you're going to have about 5 examples of these. So in 966, the question is, if I got y equals negative 2x plus 3, so we're going to graph these. What does the graph of y equals negative 2x plus 3 look like versus y is greater than or equal to negative 2x plus 3? Those are my questions here, all right? And we're going to address those. So like up here, if I was solving this, if I would have solved this, I kind of go right here. If I would have said 7 minus 9x equals 32, we'd still subtract 7. Divide, or that'd be 25. Divide by negative 9. And x would be equal to negative 2 7/9. Now, in a number line, the way that looks would be 0, negative 2 7/9. And the only number that works there would be this one. So it would just be a filled in dot, and that's all I'd have there. Okay? So an equation is just where it equals. If it's an inequality, it's got to be greater than. So you have this boundary point. It's even everything to the right, or it's everything to the left. All right? So what I want to do is I want to look at these two and say, okay, what do our solutions look like here versus here? And this is the big idea for this section, because these are the things we're going to be graphing. All right? So just going to kind of shift things up here. That is what I'm graphing. All right? So I'm going to have my first one. I may have to make a straight edge. Sorry. So for the first one, y equals negative 2x plus 3. Do I have my starting point? Yes, it's at 3. Okay, from here, so this is my starting point, or my B. Negative 2 is my M, and I'm going to put that over 1. So from here, I'm going to go down 2 into the right 1, down 2 into the right 1, down 2 into the right 1. I generally do that a few times. All right, I'm not seeing any rulers here, so I'm just going to do the best I can here and use my cards. Okay, and if I'm going to graph them, here we go. All right, there we go. So, for instance, wouldn't every point on this line, so for this x, if I put 0, this is the point 0, 3, this is the point 1, 1, this is the point 2, negative 1, and this is the point 3, negative 3. So if I put 0 in for x, negative 2 times 0 is 0, plus 3 is 3. That works. If I put 1 in for x, negative 2 times 1 is negative 2, plus 3. That's 1. That works. When I put 2 in for x, what is my y? Negative 1. Negative 2 times 2 is negative 4, plus 3. That's negative 1. And again, this guy, if I put 3 in for x, is my y? Negative 3. Negative 2 times 3 is negative 6, plus 3. That gives me negative 3. That checks. So every single point on that line is an answer for it. All right? Now, if y is greater than or equal to negative 2x plus 3, we're pretty much going to do the same thing. We're going to start at 3, because this is my b, and that's my slope. I'm going to put that over 1. From here, I'm going to go down 2 and to the right 1, down 2 and to the right 1, down 2 and to the right 1. All right? And this does equal it, so I'm going to graph it the same way. Okay? Here we go. So that's where it equals, right? Now the question is, where is it greater than or equal to? So what I will focus in a lot, and there's 2 ways you can do this. You can test points, or this is kind of like my shortcut. I need the y's need to be greater than or equal to. All right. So this is where my y's are right here. Isn't that the split in my y's? I got y's above, I got y's below. Which ones are greater than? These guys are right here. Now, aren't all these up here, and then everything on that side will work? Here's why, you guys. If I go back to this guy right here, didn't I say, okay, x's are greater than or equal to? Aren't they greater than or equal to the right or to the left? Yep, so you have to pick the right or to the left. In these guys, my y's are going to be greater than on this side or that side. So what I do is I pick this point because that's my y. That's the one y I know because it's on the y-axis. That's my y-intercept. Where are my y's greater? Up here. So that means everything on this side is going to be a solution. Very similar to, it's either to the right or to the left up here. Okay, so that's one way. That's one way I get to shade. Okay, the other way you could check to shade. And actually, I'm going to use a pen because it's kind of hard to see with all these. So another way to check to shade. You check a point. If it works, then everything works. If it doesn't work, then it doesn't work. The nicest point is 0, 0. So if I had y is greater than or equal to negative 2x plus 3, if I'm putting 0 in for y and 0 in for x, does that work? So this is 0. Is 0 greater than or equal to negative 2 times 0 is 0, and this is 3. Is 0 greater than or equal to 3? No. So this point doesn't work, so that means none of these points work, but all the other ones work. And if you wanted to, you could actually check a point that you think works. A nice point to check, wouldn't 0, 10 work? That's way up there. So I'd had y is greater than or equal to negative 2x plus 3. And if I put 0 in for y, is that greater than or equal to negative 2 times 10 plus 3? Negative 2 times 10 is negative 20. Negative 20 plus 3 is negative 17. That checks. So since this was 2, 3, 4, 5, 6, 7, 8, 9, 10. Since this guy works, all of them work. Everything on one side or the other side. All right? So that's the first one on that one. Okay? So there's a couple things you're going to have to know. First we have to do, so when we do these, so we're going to graph inequalities. I'm going to give you guys some steps. So graphing inequalities. Number 1, graph the line. And eventually we're going to graph curves. This year we're not going to graph curves, but we're going to graph the line. Number 2, decide a boundary point. All right, so in these we have filled in for equals, and we had open for not equals. For these guys, if it's greater than or equal to, less than or equal to, we're going to have a solid border, just like I did in this one. Okay, didn't I have a solid border here? Because it equaled to all of them. Less than or less than, we'll just go less than or greater than. This is going to be a dashed border because that means it does not equal, does not include those points. All right. And then the next thing we're going to do after that, you're going to shade the correct region. And that's it. That's how you do them. Okay, so I'm going to kind of get to all these here. Sorry. So we looked at question 966. They went rather into depth there. Then they also looked at, let's look at line 67 because it's super duper similar to what they did before. All right. So in this one, I'm actually just going to use this, you guys. Okay. So in 967, they want us to graph y is less than negative 2x plus 3. All right. So the 3 is your starting point and the negative 2 is your slope, which is that's where you move. We're going to start at 3. And then we're going to go down 2 into the right 1, down 2 into the right 1, down 2 into the right 1. All right. And then the next thing is, what's my boundary point, right? Because I had all of those steps. So first, graph the line, decide the boundary point. So the boundary, this is not equal to it. So what is not equal to graphically, we're going to have a dashed line. All right. And then the final thing is, we are going to shade. So you have two options. If you want to do it my way, it's the shorter way, I think. Your y's are less than. So I think to myself, these are where my y's are cut. There are some above, there's some below. Which ones are less than? The one above or below? Below. They're less than. So if this guy's on a solution, the whole side is a solution, all right? Or what we could do is we could check. I like checking 0, 0. It's right here. So I'd ask you guys, given what I just did, what do you think? Should 0, 0 work? And the answer should be yes. So we're going to go back here. Is 0 less than negative 2 times 0 plus 3? Negative 2 times 0 is 0 plus 3. That's 3. Is 0 less than 3? Yes, it is. So that's a solution, and everything else on that side is a solution. All right, so you have one with a greater than or equal to and one with just a less than. Borders are different. Shading, we got to think. All right, so that's going to bring me to question 968. And I'm going to look at A first. I'm going to try not to waste too much paper today. So I'm going to have y is greater than negative 1/3 x minus 1. All right, so the first step would be graph the line. And within that step, it's understood you have to think, can I graph the line? Sure, I can graph that line. So I'm getting kind of off there. Let's rearrange this just a little bit. Nope, not going to work quite as well as I wanted it to. Let me just flip this out. Sorry about that. And there we go. Sorry about that. All right. So the first thing I want to do is, can we graph this? Yes, we can totally graph it. We're going to start at negative 1 because that's where my y-intercept, that's where I'm beginning. My slope is negative 1/3. So from here, I'm going to go down 1 and to the right 3. So down 1 to the right 3, down 1 to the right 3, and go up 1 and to the left 3 if I want. All right. And then the next question is it going to be solid or dashed? So for me, let's see here. If it's greater than, it's going to be dashed because it's not including. All right. And for this one, it says your y's are greater. So this is my y. I got y's above or below. Which ones are greater? Above. So I would say this is my shaded region there, and that is done. If you need to check a point, which you may want to do, so checking a point, get a pen. I would check 0, 0 because it's on one of the sides. My first question would be, should 0, 0 work? Yeah, it should because it's part of the shaded region. Let's see. 0 needs to be greater than negative 1/3 times 0 minus 1. 0 needs to be greater than negative 1/3 times 0 is 0. 0 minus 1 is negative 1. Is it? Yes. And that confirms my answer. Awesome. All right. So I'm going to have to move this. And we will go on to the next one. So this is going to be B up here. Y is less than or equal to 4x plus 2. So my first question on this one is, can I graph it? And the answer is yes. My B is 2 and my M is 4. So I'm going to start at 2. From here, I'm going to go up 4 and to the right 1. Or I can go down 4 and to the left 1. Okay, now I got to figure out what kind of border I'm going to have. I'm going to have a boundary point or boundary of a solid line because it's equal to, because all these points are going to be a solution. All right. Then if you want to use my way, the y's are less than or equal to. I know it's hard to see this. So y's are going to be less than or equal to. So this is my y-intercept. I have y's above, I have y's below. Which ones are less than or equal to? These guys down here. So that means the whole side should be shaded. All right, so, and if you want me to further check, I'm going to check the point 0, 0 because that's right here. Should it work? Yes. So putting 0 in for y, 0 is less than or equal to 4 times 0 plus 2. So 0 is going to be less than or equal to 4 times 0 is 0 plus 2 is 2. Is 0 less than or equal to? Yes. So that works. All right. Okay, that brings me to C. All right. C, I have y is less than 5 halves x plus 3. Sorry. A little 4 happy there. All right, so my first question is, what's my starting point? It's 3. And where is my moving point or my slope? It's right there. It's 5 halves. So from here, I'm going to go up 5. 1, 2, 3, 4, 5 to the right 2. Or I can go down 5 and to the left 2. Okay, so those are my points. My next question is solid or dashed? It's dashed. Why? Because it's not equal to. All right. Then, where am I going to shade? Since it's an inequality, I have to shade. My y's are less than. So, where are my y's less? This is where my y's are separated. I have y's above and below. Which ones are less? Below. So, everything on this side should be a solution. And if you want to check this one, if I'm going to check 0, 0, which is right here, it should work because it's part of the shaded region. So I'm going to check, is 0 less than 5 halves times 0 plus, was that 3? Yep. 5 halves times 0 is 0. 0 plus 3 is 3. Is 0 less than 3? Yep, 0 is less than 3. That works, and everything else on that side should work. Which brings me to the last one. I'm going to actually do my math right down here. All right. So I have 2x minus y is less than or equal to 5. All right, so here's my question, you guys. Can I graph that? No. First thing I need to do is subtract 2x. So I'm going to have a negative y. Does that subtracting 2x flip this around? No. So it's going to be less than or equal to 5 minus 2x. All right, now I'm going to put a 1 right in front of here. How do I get rid of that negative 1? I divide by negative 1. All right, I'll use a pen because I know it's getting kind of light there. Negative 1 divided by negative 1 is just 1. This is going to be y. You divided everything by negative 1. This has to flip. Okay? 5 divided by negative 1 is negative 5. Negative 2x divided by negative 1 is plus 2x. So 2 is my slope because it's mx plus b. Negative 5 is my y-intercept. So for this one, I'm going to start down 5. From here, I'm going to go up 2 and to the right 1. All right, and then the next thing I got to do is decide my boundary. So on this one, and I'm actually going to put this right here. This is y is greater than or equal to negative 5 plus 2x. I put the 2 over 1, and that's my m, and this is my b. All right, if it's greater than or equal to, is it solid or dashed? It is solid. All right. And then, if I wanted to kind of do my trick, this one says that the y's have to be greater than. So, my y's are separated here. I got y's above, I got y's below. Which ones are greater than? Above. So that means all of this should be shaded. And if I want to check 0, 0, should 0, 0 work? Yes, because it's in the shaded region. So I'm going to say 0 has to be greater than or equal to negative 5 times 2 times, or plus 2 times 0. All right. 0 is greater than or equal to. 2 times 0 is 0 plus -5. Is 0 greater than or equal to -5? Yes, it is. So I have the correct shaded region. All right, I'm going to be honest with you. That's pretty much the next 2 sections. Super duper important. All right, your homework is going to be questions 970 to 976. All right, good luck.